and that too without being completely dependent on batteries. Just imagine an engine that feels like a petrol or diesel engine, but produces no emissions, eliminates charging anxiety, and can power heavy trucks, buses, and machinery with ease. That's the claim being made. Most interestingly, Cummins says that this technology isn't just a thing of the future, but that preparations are underway to bring it to the roads now. But the question remains. When Tesla, BYD, and other companies have invested billions of dollars in batteries, can hydrogen engines really turn the tide in this race? In this video, we won't just hear big claims, but we'll understand how Cummins hydrogen engine works, where it can surpass electric vehicles, and how this engine will ultimately disrupt the market. And before we move on in the video, please subscribe to the channel so you can see such videos first. If there's another name synonymous with reliability in the world of automobiles and engines, it's Cummins. For decades, Cummins' identity has been crystal clear, a company that makes heavy, robust, and reliable diesel engines. Whether it's trucks, buses, mining machinery, or industrial generators, wherever continuous operation and power were needed, Cummins' name was automatically mentioned. This was a company whose engineering was unquestionable, whose machines ran tirelessly for years, and whose customers thought only one thing when buying their products: install it once and forget about it. Cummins has never been a company focused on showmanship, big advertisements, or hype. Its true identity has always been rooted in practical work and long-lasting reliability. But times changed, and so did the direction of the entire auto industry. Suddenly, diesel was demonized, and carbon emissions, pollution, and environmental concerns became central to every discussion. Many felt that the era of companies like Cummins was coming to an end, because what would a company that makes diesel engines do when the world is moving towards electric vehicles? This is where Cummins made a decision that surprised everyone. Before abandoning diesel, the company understood that the problem wasn't the engine, but the fuel. Cummins realized that if the same power, reliability, and performance could be combined with clean energy, the game could completely change. And this is where the journey from diesel to hydrogen began. This wasn't a sudden decision, but the result of years of thought, research, and practical experience. Cummins knew that EVs wouldn't work everywhere, especially in heavy trucks, long-haul transport, and the industrial sector, where waiting hours for charging isn't an option. In this context, hydrogen seemed like a path that could combine the power of diesel with a clean, future-oriented approach. The biggest risk was that Cummins was daring to gradually move away from its strongest identity: diesel. This wasn't the risk of a startup, but the gamble of an established giant with much to lose. But Cummins understood that if change was resisted, the company would become history, and if change was embraced, that history would be repeated, but in a new form. Moving towards hydrogen wasn't easy. The infrastructure wasn't ready, the costs weren't low, and the market wasn't fully prepared. Despite this, Cummins invested, worked on the technology, and put its engineers on a new mission. The most interesting aspect of this decision is that Cummins doesn't view hydrogen as a fad, but as a practical solution. The company believes that the world cannot be driven down just one path. EVs, hydrogen, and other fuels will all have their roles to play. Cummins' risk lies in betting on a future where power, reliability, and environmental responsibility go hand in hand. What exactly is a hydrogen engine? When people hear the term hydrogen engine, most immediately picture some highly complex lab-type technology. But the truth is, understanding a hydrogen engine isn't as difficult as it's made out to be. In simple terms, the purpose of a hydrogen engine is the same as any other engine: to power a vehicle. The only difference is that where diesel or petrol burn to produce power, here hydrogen is used as the fuel. Hydrogen is a very light gas, and when used correctly, it produces energy without emitting smoke or soot. In most cases, it only produces water. Now, let's understand this in an even simpler way. Just as you fill up a diesel engine with fuel, a hydrogen engine is filled with hydrogen. Inside the engine, this hydrogen is used in a controlled manner, generating power and making the wheels turn. For the driver, the experience remains largely the same. Start the engine, press the accelerator, and the vehicle moves. This is why many companies, especially Cummins, consider hydrogen not as a direct competitor to EVs, but as a different and more practical alternative. Now the question arises, how is it different from EVs? The biggest difference is battery versus fuel. Electric vehicles have a large battery that needs to be charged. Charging takes time, sometimes half an hour, sometimes several hours, and as the battery ages, its capacity decreases. On the other hand, a hydrogen engine eliminates the hassle of charging. The idea is that, just like filling up a petrol tank in 5 minutes at a petrol station today, hydrogen can be refueled quickly. This means no long waits, and work continues uninterrupted. The second major difference is weight. The battery in an EV is very heavy, especially in large vehicles and trucks. This increases the weight of the vehicle and affects its load-carrying capacity. A hydrogen system can be comparatively lighter, which shows greater advantages in heavy vehicles like trucks and buses. The third difference lies in the method of use. EVs are great for cities and short distances, no doubt about it. But where you have trucks running day and night, mining machinery, or long-distance buses, charging for hours at a time isn't practical. Hydrogen engines fit better here because the work doesn't stop. Now, it's important to clear up another misconception. A hydrogen engine doesn't mean just one technology. Some systems generate electricity from hydrogen to power the motor, while others offer an engine experience similar to diesel, only with a different fuel. For the average person, it's enough to understand that in both cases, pollution is reduced, and the function remains the same, driving the vehicle. Another reason for the difference from EVs is familiarity and habit. Millions of drivers and mechanics worldwide are accustomed to internal combustion engines. Switching to a completely electric system overnight isn't easy for them. Hydrogen engines act as a bridge between old habits and new thinking. The driver doesn't experience a drastic change, but the environment benefits. This is the thinking that's driving companies like Cummins in this direction. They believe that the future won't be built on just one path. EVs, hydrogen, and other fuels will all have their place. Hydrogen engines are for those areas where EVs are still struggling. And perhaps that's why people are now asking, is the hydrogen engine an enemy of the EV or its partner? The truth is, the hydrogen engine hasn't come to compete with EVs, but to fill the gaps where batteries haven't yet proven fully successful. This is its real strength, and that's why it's generating so much discussion these days. Why is hydrogen more suitable for heavy vehicles? When it comes to small cars or vehicles used within cities, electric vehicles seem perfectly fine. But as soon as we enter the world of heavy vehicles, trucks, buses, mining machines, construction equipment, and large machines used in factories, the story changes. This is where the true power of hydrogen becomes apparent. Simply put, heavy vehicles have different needs, and hydrogen is a better fit for those needs. First, let's talk about weight. If a large truck or bus were to be electric, it would require a very large battery to power it. This battery is so heavy that it often significantly increases the vehicle's own weight. The direct consequence is that the truck can carry less cargo, the bus has reduced passenger capacity, and the mining machine becomes less efficient. A hydrogen system can be lighter in comparison, as it doesn't require such a heavy battery. This allows the vehicle to carry more weight and perform its intended function properly. The second major factor is time. Heavy vehicles are generally not designed for intermittent operation. Long-haul trucks operate day and night, buses run continuously on fixed schedules, and mining machines often work 24 hours a day without stopping. Now imagine if such a machine had to be plugged in for charging every few hours. How much slower the work would become. Electric charging takes time, even with fast charging. This is where the concept of hydrogen refueling comes in. The tank is filled in a few minutes, and the vehicle is ready to go again. This is what makes it more practical for heavy vehicles. The third point is distance and reliability. Heavy trucks often travel hundreds of kilometers. The issue of range always remains with EVs, especially when the truck is fully loaded. As the weight increases, the battery drains faster. This concern is somewhat reduced with hydrogen, as it can be designed for longer journeys. Drivers don't have to constantly worry about whether they'll find the next charging station. This is why logistics and transportation companies are starting to take hydrogen seriously. The fourth and very important point is the working environment. Mining sites, mountainous regions, deserts, or extremely cold places, EVs don't perform the same everywhere. Battery capacity decreases in very cold temperatures, and there are also problems in very hot environments. A hydrogen engine can operate more reliably in such challenging environments because its system is based on engine technology, which the industrial sector is already familiar with. This is why companies like Cummins are promoting hydrogen specifically for commercial and industrial use. Another major aspect is cost and operation. Replacing or repairing batteries in heavy vehicles can be very expensive. If a large battery fails, the cost can run into the millions. The maintenance approach for hydrogen systems is slightly different, and in the long run, it may prove more cost-effective for many operators, especially those companies that are already working with engine-based machinery. Furthermore, driver and mechanic training is also a factor. A completely EV system requires new skills and new tools. A hydrogen engine, in a way, bridges the gap between the old and the new. For those who have been working with diesel engines for years, this transition becomes somewhat easier. This is why the industry is viewing it as a smooth transition, not a sudden shock. Finally, let's talk about the environment. Heavy vehicles are the biggest polluters. There's no doubt about that. If these same vehicles start using clean fuels like hydrogen, the impact could be enormous. The air in cities, mining areas, and industrial zones, the difference would be visible everywhere. This is why hydrogen is considered a strong alternative for heavy vehicles. The infrastructure challenge. The biggest obstacle or the biggest opportunity. Whenever hydrogen is discussed, the first question that arises is, okay, we understand the technology, but where will we refuel? This is where hydrogen infrastructure becomes both the biggest problem and the biggest opportunity. The reality today is that hydrogen stations are very few. Petrol pumps are available in every city and on every highway, and EV charging stations are also gradually increasing, but hydrogen stations are still few and far between. This is why many people immediately say, hydrogen won't work. But the story doesn't end there. The real story begins here. First, let's clearly understand the problem. For the average person or truck driver, the biggest concern is reliability. What if they run out of fuel on the road? This is the biggest fear with hydrogen today. No company or driver wants to fully switch to hydrogen until they are confident that fuel will be available at every required distance. This is why the initial adoption rate of hydrogen seems a bit slow. This fear is justified because no technology can take off without infrastructure. But now, look at the other side. This very shortage can become the biggest business opportunity of the future. Remember when CNG was new, the same thing was said. There are no stations. How will the cars run? The same question arose with EVs. Where will we charge them? But as the number of vehicles increased, the number of stations also increased. The same pattern can be replicated with hydrogen. The only difference is that the starting point here won't be ordinary cars, but rather the commercial and industrial sectors. Trucks, buses, mining machines, and vehicles operating within factories typically travel on fixed routes. Their paths are predetermined. The same mining site, the same factory, the same logistics corridor. In such cases, there's no need to spread stations across the entire country. Building hydrogen stations at a few selected points is sufficient. This is why many companies are viewing hydrogen more as a fleet fuel than a public fuel. This is where the infrastructure business model becomes clear. Now imagine, if a hydrogen station is built in a large logistics hub, port, industrial zone, or mining area, not just one or two vehicles, but hundreds of vehicles will refuel there. This means continuous demand, continuous use, and continuous revenue. This is where investors and large companies are showing interest. A hydrogen station can become not just an expense, but a long-term source of revenue. This is also a great opportunity for governments. Many countries are already emphasizing green energy and clean fuels. If governments support hydrogen infrastructure through subsidies, tax breaks, or policy support, this sector can grow very rapidly. Just like EV charging, hydrogen stations can become the new normal in the future, the only difference being that this change will happen gradually and thoughtfully. Another important point is that hydrogen is not limited to vehicles. These same stations can later become centers for electricity generation, industrial use, and backup energy. This means that once a station is built, multiple avenues for its use open up. This is why some experts believe that those who invest in hydrogen infrastructure today will be at the forefront tomorrow. This same thinking is reflected in the decisions of companies like Cummins. Cummins isn't just looking at engines, it's looking at the entire ecosystem: fuel, supply, usage, and future needs. The company believes that while a lack of infrastructure may seem like an obstacle today, it could become the biggest advantage tomorrow. Because, while others are waiting, those who are prepared will be the ones to capture the market. The lack of hydrogen stations is a major challenge today. There's no doubt about that. But this very challenge can also open the door to employment, investment, and new businesses in the future. The question isn't when the infrastructure will be built. The real question is, who will have the courage to build it first? And history often shows that those who take the risk first are the ones who reap the greatest rewards. Impact on the global market. When the discussion of hydrogen engines is limited to just one country or one company, the impact seems small. But as soon as this discussion reaches the global market, the picture changes completely. Hydrogen is no longer just a new technology, but a potential turning point for the entire auto and energy industry. Different countries around the world have different needs. Some have a high volume of long-haul trucks, others have a large number of mining and industrial machines, and some have very strict environmental regulations. In this context, hydrogen emerges as an option that can address the problems of many countries simultaneously. The first impact is seen in countries where logistics and heavy transport are considered the backbone of the economy. The US, Europe, Australia, and some Asian countries are heavily dependent on large trucks and buses. Here, a limitation of EVs is clearly visible: charging time and range. If hydrogen engines are gradually adopted in these markets, it will impact transportation costs, time, and reliability. Companies will be able to make faster deliveries, and supply chains can become more stable. This means that global trade can also accelerate. The second major impact is on countries that are heavily dependent on oil imports. Even today, many countries import the petrol and diesel they need, which puts a strain on their economies. If these same countries shift towards hydrogen, especially green hydrogen, they could gain some energy independence. This would reduce their dependence on oil and could even lead to changes in geopolitics. Countries with the capacity to produce hydrogen from solar, wind, or water resources could become new energy exporters in the future. In markets like Europe, environmental regulations are very strict. They consider not only the vehicle's operation, but its entire life cycle, where the battery is manufactured, how it will be recycled, and its overall environmental impact. In this context, hydrogen is being considered a balanced option, especially for heavy-duty vehicles. If hydrogen receives adequate support in Europe, the focus of the automotive industry there will not be limited solely to EVs. This will force global companies to change their strategies. The story is slightly different in Asian markets. Here, there is a larger population, rapid urbanization, and continuously expanding industrial zones. Countries like China, Japan, Korea, and India are working on hydrogen at varying levels. Japan and Korea have long considered hydrogen the fuel of the future. If hydrogen engines are adopted on a large scale here, it will impact the entire supply chain, from raw materials to technology and the job market. This could also create significant pressure on automotive companies in the global market. Companies that have already bet solely on EVs may have to reconsider their strategies. Realigning investments, research, and planning is not easy. This is where the strategy of companies like Cummins comes into play. Cummins has maintained from the beginning that the future will not be a one-way street. This approach could strengthen its position in the global market, as it is trying to provide solutions tailored to the diverse needs of different countries. Another major impact on the global market could be seen in the form of investment. As confidence in hydrogen grows, money will flow into infrastructure, research, and manufacturing. New startups, new jobs, and new industries could emerge. This is the same pattern that was previously observed with EVs and renewable energy. Ultimately, the most important point is that the impact of hydrogen will not be sudden. It's not an overnight change, but if some major markets adopt it in the next 5 to 10 years, the balance of the global auto industry could shift. EVs, hydrogen, and other fuels, all three together could create a new system. And this change could make the global market more resilient, more stable, and perhaps more sustainable. Why is this a wake-up call for Tesla and BYD? Whenever a new technology emerges, people immediately label it a threat or game over. But in the case of hydrogen engines, the situation is slightly different and more nuanced. It's not a direct attack on EV companies, but rather an alternative that highlights some of their weaknesses. The level to which Tesla and BYD have advanced EV technology is a significant achievement in itself. However, the limitations of EVs are now becoming clear, especially in heavy vehicles, long-distance travel, and continuous commercial use. This is where hydrogen poses a challenge. If companies in the truck, bus, and industrial sectors start choosing hydrogen over EVs, the EV companies' dream of capturing the entire market might weaken. The threat isn't because EVs are bad, but because EVs aren't suitable for every need. Hydrogen can fill this gap, and that's what makes it a cause for concern for EV companies. The biggest strength of EV companies is their battery and software technology, but this can also become their biggest challenge. Batteries are heavy, expensive, and don't perform consistently everywhere. As the size and function of the vehicle increase, the battery problem also escalates. Hydrogen engines reduce this pressure because they operate on a fueling concept rather than charging. This allows for faster and more consistent operation. If logistics companies and industrial players begin to believe that hydrogen is more reliable for their operations, EV companies will have to reconsider their focus. This is why it's a wake-up call. The entire market won't belong to EVs. It could be divided. Cummins's real strategy. Why is everything at stake? This is where Cummins thinking comes into play. Cummins believes that the future will not be a one-size-fits-all EV solution. That is, a single technology won't be suitable for every country, every sector, and every application. Cummins has learned from experience that the world